So welcome, everyone. If maybe some of you already heard this and some of you didn't, we were having a little bit of technical difficulties, but I just wanted to welcome you. I'm Scott Weaver, Senior Climate Scientist at Environmental Defense Fund, and I just wanted to welcome you to our webinar tonight, Responding to Arguments by Climate Change Skeptics, which will be presented by myself and Alyssa Akko. We work as a team here in the climate science world at EDF, doing a host of different things, one of which we're happy to do tonight, which is inform folks outside of science and also within science about some of our work and how we view the climate science landscape. We do this through many different ways. We conduct our own research. We do outreach as we're doing today, and we really try to inform the conversations around science and policy using grounded truth and facts in the scientific method. My background, I come from more of a meteorological climate science background. You'll find that climate science is very broad and is comprised of people coming from many different backgrounds. And that's one of the great things about it, is that it's highly interdisciplinary. And having a team approach, as we're doing tonight, really allows us to leverage our different strengths. And I think you'll see that come through tonight. Right now, Alyssa and I are 2/3 of the climate science team. We're soon to have a fourth member, and we're very excited to be here tonight. And I'm going to kick it over to Alyssa and allow her to introduce herself.
Thanks, Scott. So I am Alyssa Akko. I am a climate scientist at EDF. I've been with EDF for a few years now. I'm going on 4 years. It's been really great coming from the academic world to the Environmental Defense Fund and advocacy organization, because I'm exposed to so much more than just pure science. I'm able to relate science to, policy and communications, and it's just this really beautiful interface of all of these interweaving realms of climate that, that play a big role in going forward and solving the climate change problem. So Scott and I today are going to go into a lot of details about some of the most popular arguments and tell you, what the science really says behind these arguments that are typically used by climate change skeptics that call themselves that, but even by some people that just really don't know that much about climate change, and so they may hear things, they don't really know what to believe. Obviously, there's so much information on the internet, not all of it is true. And so sometimes you just may get asked, very innocent questions about, well, I thought it was the sun that's causing climate change. And so here tonight, we're just trying to give you some nuggets of truth of what actually is going on in the system. And then at the end, before we go into the question and answer part of this, we're going to provide you with some of our favorite resources so that you can also, know where to go on the internet to find the answers to a lot of these questions and arguments that you may get thrown at you. And I just want to be clear that even as climate scientists, Scott said that it's such a big space, so the two of us together don't necessarily know everything. And so he's saying he comes from the meteorology world. Well, I personally study greenhouse gases and aerosol emissions from human activities. So there's a lot that we, are always learning. And so we use these resources ourselves to, be able to answer questions that we get by our friends and family and communities. So then after that, we will go into question and answer. So these most popular, let me see if I can advance the slides. Hold on, I'm having trouble advancing the slides, but while I fix that, we have divided the most popular arguments into 4 main categories to just kind of, put everything into, similar areas of science so that it'd be easier. And the first category that we're going to go into is it's not happening. And this is usually the first tier of climate denial, which is that denying that it's even happening. And then the second category is that it's not us. And so some people say, okay, yes, it is happening, but it's not human. So we'll go into some of the arguments there. And then the third category is it's not bad. So even the people that think, okay, it's happening and it's us, well, it's really not that bad. I've heard things like we have air conditioning and we like when it's warm. So, you know, those types of arguments. And then the fourth category is it's too hard. And what that means is that, you know, okay, it's happening, it's caused by humans, maybe it's bad, but it's too hard for us to fix. And so that's something that's, we hear more and more today, which is that, you know, solving it is just too difficult. So I'm going to toss it over to Scott, who will go into that first category. Again, now the slides are working. So these are the 4 categories, and you don't need to read too much of the different arguments underneath them right now, but these are the arguments that we will be going through specifically when we get to that category. So Scott's going to go into the it's not happening, and I'm going to toss it over to him right now.
Great, thanks, Alyssa. So yeah, we're going to start off with the first pillar. That it's not happening, and that's the perfect slide. One of the arguments, first of all, if you ignore, obviously if you ignore that a problem exists, then you don't have to worry about it, and that's probably not a great approach to take in many aspects of life, and certainly not when you're talking about things that are important basically to every living thing on planet Earth. So the it's not happening pillar is a really interesting one to start off with. Some will say it's cooling. Usually this comes from the recognition or the observation that maybe for a couple of years a certain town in a certain country perhaps that covers a very small area of the Earth may have not had a large warming trend, even though the Earth as a whole has. And the analogy I would make there is that it's much like the numerous stocks that make up one of the financial stock indices, right? I mean, you could have one of them trending down while the index itself is rising. But it's not just, even if you just forget about that and look at the global temperature that we see is rising, it's not just temperature. There's many other things that we have to look at. Science and scientists are, by their very nature, very, very skeptical. And so what we like to do is, before we believe in a conclusion, we like to come at the issue from many different angles and try to get to look at many different ways to produce evidence. It's much like building a case. If you ever watch a courtroom drama television show, it's not just one piece of evidence. You want to go after multiple pieces of evidence to make your case. And so that's what's shown in this slide, that it's not just global temperature. We're seeing changes in how certain animals migrate. Our satellites are telling us there's less snow and ice, especially in the Arctic, and we'll talk a little bit more about that later. The oceans are warming. We know we can measure the sea level rise. If you've been following the news, there's been really massive coral reef bleaching in the Pacific Ocean. And so, we're seeing all these things, and then even into the weather realm, which is what I'm more familiar with. We see increases in heat waves, and so it's more than just, hey, the global average temperature is rising. We're actually seeing impacts coming from many different lines of evidence. Next slide, please. Okay, so the temperature record is unreliable. This is another one that's really interesting. One of the great things about science and having different scientific agencies across the world looking at these temperature records in many different ways is that they can independently observe, measure, and collate their temperature records and then compare them with other folks. And so we have this going on, not just from the temperatures that we record, at the ground, but also from satellites, ships. There's all these different measurements that we can use, even going really far back, using what we call paleoclimate records. And that's when you look at records, the temperature records that you can get from trees or long-term ice formations or sediment and rocks and shells. And then we try to use computer models to try to understand why that would occur. And in addition to that, as I mentioned previously, you have visible indicators of warming. And so this is just, the case is just overwhelming based on an overwhelming amount of data. that we can agree that the increases in global temperature is real, it's observable, and it's indisputable. So next slide, please. One of the great tricks that some climate skeptics or denialists will try to use is to ignore the long-term record, right? So if you can do that, you can perhaps find a time period in history when maybe the temperature wasn't increasing as much. Typically, this means you're looking at a shorter time period. So what you're looking at here is the temperature, the every year's temperature from 1880 to 2016. So that's a 137-year temperature record. These are anomalies, which are basically departures from the average. But really, the main take-home message here is that you see an increase over time. Prior to 2015 and 2016, it was a common skeptical argument to start with 1998. So say we were back in 2014 and say, hey, the world really hasn't warmed all that much since 1998. The trend is flat. Well, there are also, in addition to the increasing trend, there are these natural cycles that occur in the climate system. One you may have heard of is El Nino or La Nina. Typically when you have an El Nino event, which is natural, it's pretty much separated from what we call long-term climate change. The global temperature is warmer in that given year, just for that 1 year. And so by starting at that point, they were artificially biasing the starting point. The thing, though, is that more recently, in 2015 and 2016, we've set records actually in 2014, 2015, and 2016. So each of the last 3 years has been successively warmer and has broken the previous year's record. So this point actually doesn't hold up anymore, even if it kind of did back in 2014. But even when that was there, you could still look at the long-term record. So we call this cherry picking. You're cherry picking your start and end date and saying, hey, there hasn't been any increase in there over that time period. Next slide, please. Okay, so this is another interesting one, is that we'll say, well, the ice caps are actually increasing if you look at the Antarctic when compared to the Arctic. Could we advance to the pictures on the slide, please? So maybe advance the slide one more. I'm only seeing, there we go. There might be another one. There we go. So the consensus is that, this is their argument, is that there's a net loss of ice, but you have to understand there are regional differences. And the way I would explain this is that you can have certain regions of a large area. Let's think of the United States. You could have drought in the west and flooding in the east, which are both related to changes in climate. But if you were to average them across the U.S., you would get kind of a net nothing. It would be a net neutral. And so this can happen even with the sea ice. Now, if you look at Antarctica, which is near the southern pole, if you look at the left graphic, you could see that the mass of the sea ice, is going down when you look at it regionally, even though the trend is less when you look at the total. So it's basically you have to really look at the different regions and see, why might one part be gaining and one part be losing. What we have observed over the Arctic is that the loss of ice has been dramatic. And in the next slide, I'm going to show some pictures related to that. Now, I will caution you that, again, we want to look at trends, but this is so striking. Can you go back one slide, please? The pictures are so striking here that it's really interesting to show. So here's what you're looking at now. You're looking at
sorry.
Yeah.
We seem to be having some technical difficulties with the slides, Scott. I apologize.
That's all right. That's all right. So what's really interesting about this is if you look at the lines around the pictures, you'll see that's the average of where the ice would normally be. Doesn't look too dramatic when you look at the Arctic, right? It looks like it's pretty close to where the average should be. Not all that dramatic, but the truth is actually believe it or not, even despite that picture looks like a small difference, there are a couple other things to consider. One, it's actually not a small difference. But two, it's not just the extent of the sea ice, it's also how thick it is. So you can't tell that from this picture. But in the Arctic, this picture may not show the dramatic sea ice minimum that we're seeing over the past couple of years. I'll show another figure in a minute that'll highlight that. Now, if you look at Antarctica in the recent time, you'll see that the ice has retreated below its average. So in both of these, currently, we're at below average. But the reason why I say I want to caution you is because just like I mentioned the deniers will cherry pick, we also have to be careful of that. But these are some dramatic changes. If you go to the next slide, please. Okay, so what we're showing here is, really sort of highlights the recent situation in the Arctic. And that is that if you look at the sea ice extent, if you just focus in on the light blue line that is for 2016 and 17, you don't really have to worry about the other lines, but you'll see that it's below all of the other recent years and well below the averages, which are in gray. And so the sea ice extent, the expanse that I showed you in that picture, didn't look that dramatic, but when you do an average over the Arctic and look at how different it is from previous years, it's quite dramatic. But as I mentioned, it's not just the sea ice extent, it's also the volume or the thickness. And if you look on the right side of this figure, you'll see that 2016 and now 2017 is coming in really, really low. So we're at our lowest sea ice in terms of concentration and extent in the Arctic since we've been looking at satellite records over the last 37 years or so. Next slide, please. Okay, back to Alyssa for It's Not Us.
Hi, everyone. Thanks, Scott. I'm hearing that some people are having difficulty either seeing the slides or they're seeing the wrong slides, or maybe even an old deck that was somehow that was uploaded into here earlier. And so we really apologize if you're not seeing the right graphics. But so we're going to go ahead and I'm just going to, talk and not use the graphics, and then hopefully afterwards when, we send around follow-up stuff, we can share those visuals with you. So basically, in the It's Not Us, one of the biggest arguments that we get is that climate has changed before and is always changing. And when people say that to me, that, but don't you realize that the climate has always changed? Some people think that I think that it's like just happening now and it's been stable before then. So my response is always like, of course. Like, it's definitely changed before and it's always changing. We absolutely know that. We have a lot of different neat tools for us figuring out what the climate looked like in the past. The difference today is that we're the ones that are kind of nudging this change. And so what I mean when I say that is that the Earth's climate is determined by this energy balance of incoming sunlight and outgoing heat. And there are a number of natural factors that can affect how much sunlight we actually get. For example, if you have clouds in the sky, if you have a big volcanic eruption, if you have an ice surface, if any of you have gone skiing and sometimes you get sunburned, that's because the sun reflects so strongly off of that snow that you're skiing on that you actually get more sunlight in your face than you would, on a day in the summer. And so all of these factors change how much sunlight we have. And so if these factors change, which they do over time naturally, then that can change our energy balance. What also can change our energy balance is how much heat actually can escape to space. So if Earth didn't radiate heat back out into space, then it would just keep getting warmer and warmer and warmer from all of the sunlight that we're getting every day. And clearly that doesn't happen. It would be way too hot here for us ever to survive. And so what the Earth does is it kind of lets off this radiation in the form of heat, and that escapes back to space. Now, greenhouse gases in the atmosphere that are there naturally, they keep some of this heat in the Earth system and prevent it from going out to space. This is natural. We need this. Without those greenhouse gases, the Earth actually would be completely frozen and 60 degrees Fahrenheit cooler. So this is a good thing that we have an atmosphere and that we have greenhouse gases. The problem today is that we're actually changing the amount of greenhouse gases in the atmosphere. So you can think of this as a blanket. We're just putting more and more layers of thickness to our blanket. And so it's trapping more of our body heat at night, and so we're getting warmer. And so that's why, even though the climate has changed before, that's how we kind of reconcile this. Well, the climate can change without us, but it also can change with us. So the next argument that we hear all the time that I mentioned earlier is it is the sun. We hear that it's not humans, it is the sun. And so there are two main reasons that we know that it is not the sun. The first is that the upper atmosphere is actually cooling. The upper atmosphere would be warming if the sun was getting brighter and hotter and heating us more. The second is that we actually can measure how much sunlight is coming off of the sun and into our planet system. And the trend of that sunlight that's reaching us every year does not match whatsoever with the trend of the increase in global temperatures. So if you can think of the global temperatures just going up and up and up over the past century, and then you look at the amount of sunlight we're getting, and it kind of has this 11-year cycle of dipping and then peaking and then dipping again. And so it's just these two trends are just completely uncorrelated, and so it does not make sense that one would be causing the other. And so I just want to re-mention before I move on that we will be sending this PowerPoint out. You will see these slides. They're full of graphics and infographics and whatnot with the text, so you'll be able to, have this as a resource in the future. And we'll just do our best right now in explaining things to you verbally. So the third argument in this "it's not us" category is that there's no consensus. People think that, okay, like I get that some people think it's humans, but, there's still a debate. Scientists don't know. We need to do more research, all those types of things. We hear that all the time, especially from, the current administration and people related to that line of thinking. And so there are actually several lines of evidence that humans cause climate change, and there is near unanimous consensus among experts. And so these lines of evidence, which independently show that humans are contributing to climate change, but also together give an overwhelming support that it's humans, are number one, simple chemistry that we've known since the 1900s about how when we burn a carbon-based material, it emits carbon dioxide. This is very simple stuff. Number two, basic accounting, which we've been doing since the 1970s. We've been monitoring how much of these carbon-based materials, like fossil fuels, we burn, where, and what process. And so, as you can imagine, using our simple chemistry and our basic accounting, we can figure out how much CO2 we would be emitting. We also can measure CO2 in the atmosphere. We've been doing that since the 1950s. We have some really strong records in really remote locations that are far away from pollution sources. And number five, basic physics, that we've actually known since the 1820s, that carbon dioxide will absorb heat, and it will increase the temperature of its environment because it absorbs heat. This is, again, very simple stuff. Number six, we can monitor climate conditions. We've been doing that since the 1930s. We can figure out what is going on not just with the temperature, but also with the sea level. We can figure out what's going on with glaciers. We can see that with our own eyes. People have photos from 20 years ago of certain glaciers, and they have photos of them today, and you can just see with your own eyes that something is going on because all of these glaciers are melting. Number seven, we're able to rule out natural factors, and we've been doing that since the 1830s, where we figured out that different solar cycles over much longer periods of time than the 11 years that I talked about can actually play a strong role in influencing the climate when they kind of trigger these big changes in the climate, and then other factors come into play. And so we have a good understanding of all the natural factors that are working in the climate system. So it's not that, we stop at humans and say, this is it. We look at everything, and there's nothing else that can explain this like humans can. And number eight, we can employ computer models. So a lot of people pick on computer models as the weak link. Well, it's only one of these 8 lines of evidence that we have. And we've been actually working on computer models since the 1960s. The first one was in the 60s. And so these aren't tools that we've just come up with today. These are tools that are made full of mathematical expressions that do an excellent job of reproducing Earth conditions much like a video game would. It creates this virtual world where we're able to play around and see what happens in different situations. And we've been fine-tuning these models for decades. And so when you add up all of these lines of evidence together and you have tens of thousands of climate scientists at different countries, at different institutions, looking at all this evidence on their own, 97% on average have come to their own conclusion that yes, humans cause climate change. And now the final argument for this category of it's not us is models are unreliable, and this was related to what we were just talking about. Even if we got rid of models, we have plenty of evidence that humans are to blame and are responsible for the majority of climate change. But models themselves are actually really great. They can do pretty amazing things. They can reproduce a lot of different types of situations. We can use the same model to see what happened during, for example, the age of the dinosaurs or an age of an ice age. And by inputting the right properties into the model to drive that model, we get what the climate looked like at different periods of time and also today. And so climate models get a bad rap, but they're actually really great tools that we use to supplement everything else that we know. And it's important to know that human decisions actually introduce a lot more uncertainty than our limitations in our understanding of the climate system. So when you see these projections that are on these charts that are kind of all over the place and have this huge range, a lot of that is just because we don't know what's going to happen with our decisions on which policies to enact, which sectors that we want to start reducing emissions from. So it's all of those different scenarios that we have to consider when figuring out what's going to happen in the future. So now I'm going to toss it back to Scott. He's going to go into why the arguments that we hear for it's not bad.
Thanks, Alyssa. That was really great. So it's not bad. So some folks will get through the fact that it's happening. They can accept that. They can get through the, hey, maybe it's us, but it's really not that bad. And, you know, plants take in carbon dioxide. So isn't that just increasing plant food? The short answer on that is, sure, CO2 is essential for plant growth. But that's, again, this is that line of thinking where we cherry pick one thing. They don't necessarily need any more. Our vegetation seems to be doing fine with the amount that they have. But you know, you have to get into impacts. So let's concede that maybe CO2, you know, is okay for plants. That's what they take in and they give off oxygen. But if you're changing the climate, if you're causing actual climate changes where you're increasing things like heat waves, you know, there's another need that agriculture has, and that's water. And so if you're either getting too much water through floods, you're damaging crops, or if you're increasing the incidence of drought. And as we know that heat waves are increasing, the chances that you're going to have more drought over agriculturally sensitive regions, or shift the climate in such a way that, you know, the really vital monsoon rainfalls that occur in different places around the world may be interrupted, or even, you know, too much of a good thing, then you're starting to get into the negatives outweigh the benefits. You can also think of it in terms of health. Sure, in the winter, if it's a little bit warmer, maybe that wouldn't be, you know, warmer winters perhaps it might mean fewer deaths. But, you know, when we get into the later projections of climate change, you know, some areas of the world, you're not even going to be able to work outside during the day in July anymore. And so, you know, there's going to be heat-related illnesses and stress on human health. The real big economic worry that most folks have is the melting glaciers, right? So if you concede that the Earth is warming, it's not too difficult to draw a line to the fact that land glaciers will melt. And so all the ice that's locked up on the land, as that melts, it eventually makes its way through rivers, through streams, through soil, you know, eventually makes its way to the global oceans. And sea level rise is very non-discriminating. And, you know, so when water is melting into the ocean in the Arctic, it's raising global sea level rise. And as our population becomes more vulnerable as we move towards the coast and have recreation and things like that on the coast, the economic implications of that are quite severe. So, you're talking about the outweighing of the negative from what we see is way more than any, small benefit that might, occur over a certain region. So that's one issue. The other thing is that some people say, well, it's not bad. Animals and plants can adapt. Again, one size does not fit all here. There are some animals who may be able to what we call outrun the climate change. So you might have some kind of mammal that may be able to migrate fast toward the north. Let's say you're in the United States over the Great Plains, they may be able to make it further north. But other plants, and especially plants, they're not able to move that fast. And so we're changing the climate so fast that they really can't keep up. Some of the climate changes we're seeing over the last century, before humans were around, would take hundreds of thousands of years to occur. And so it's not just that we're changing it by a certain amount of degrees, in temperature. It's the speed with which that's occurring, and that's really a huge issue when you're talking about ecosystems. So I'm going to actually kick it back to Alyssa for the last of the four, and it's too hard, which is now getting into solutions.
Oh, okay, now I am back unmuted. Thanks, Scott, very much for all of that. And the it's too hard is kind of a new category that we've heard over time. So I may be pretty young, I'm an early career scientist, but I remember when I, started learning about climate change in college, most of the arguments were about, is this actually happening, and what role are humans playing? And now it's moved a lot into the it's too hard category. So a lot of the questions that I get are, that CO2 limits are going to harm the economy, that CO2 limits will make little difference, that China isn't doing anything. So those are some of the arguments that we're going to cover right now. And so first, I will go into that CO2 limits will harm the economy. And this is just not true. It's very unfounded. There's no reason why it's one or the other. We've seen California, for example, reduce their emissions of CO2 by growing their economy. They're one of the largest economies in the world, and it's only one state of the entire U.S. And so we definitely don't see that connection that people are kind of claiming. And here are some examples that I want to give you about what could happen to the economy if we don't act on climate. So one part of this is that, like I said, we're not seeing that CO2 limits are actually harming the economy, but the other side is that if we don't do anything to address CO2 emissions, it's going to harm our economy way worse than any kind of actions that we could take now. So I'll just give you some examples of that. So for example, sea level rise. Some reports say that coastal properties in the U.S. will suffer $5 trillion in damages through 2100. So this is a business as usual case if we don't take action. For food, we have studies that show that food prices globally may increase by over 80% by 2050. That the $4.1 billion dairy industry in California is expected to suffer annual losses from $300 to $900 million. The economic impact of ocean acidification on shellfish, mollusks account for 10% of fishery production, which is growing in demand, and that could cost more than $100 billion cumulatively by 2050. And those are just some examples of many, many, many that you can find in the scientific literature of what are happening. So I'm only giving you a tiny slice of what we've actually been able to find about what will happen in the future to our economy if we don't do anything. And so the last example I'll give you is water. And so we're expected to see water shortages in California's Central Valley that will likely lead to an economy-wide annual loss around $6 billion during particularly dry years. And we've already seen that California has had one of its, driest stretch of 5 years that it's ever had. Studies show that in 1,000 years the drought hasn't been that bad. And so we expect that to happen in the future with increasing emissions and increasing climate change. And so all of these things would devastate the economy. And so it is really in our best financial interest to act now to prevent these damages from occurring. So the next argument that we see for it's too hard is that CO2 limits will make little difference. This is just not true. I really don't know how else to say it because there is a clear connection between CO2 emissions and rising temperatures. And CO2, for those of you that don't know, is a greenhouse gas that can last for hundreds of years in the atmosphere. So in the first 10 years, the CO2 hasn't been taken up by the oceans and the biosphere, then it actually can stay in the atmosphere for thousands of years. And so 20% of the CO2 that we emit today will still be there in 1,000 years from now. And this is why carbon dioxide is such a problem, because every time we emit more CO2, we are just committing ourselves to more warming in the future. And so the amount of overall CO2 that we emit into the atmosphere has a direct connection to how much the planet warms. And so as you can imagine, if we stop emitting as much CO2 and start reducing our emissions, then the temperature in the future will go down. It will peak at some point, and then it will continue to go down. It is also important to say that because CO2 lasts for so long, if we stopped emitting all CO2 tomorrow, it doesn't mean that temperature would go back to what it was in pre-industrial times. That won't happen because the CO2 we've already emitted since the Industrial Revolution is still going to be there. A huge chunk of it is still there right now. But we can definitely slow that rapid rise in the warming, and then eventually over time, as different ocean and biological processes are able to take CO2 out of the atmosphere, we can level off that warming and prevent some of the most disastrous catastrophes of climate that we're all afraid will happen. It's not too late to do that. We absolutely can do that, and CO2 limits will make a huge difference. So the next and our final argument that we will talk in detail about tonight is that, let's see if, okay, so that last argument is that China isn't doing anything. And I threw this in there because this is probably the most popular argument that I personally hear these days, that, you know, when people are kind of coming around to the idea that it's humans and we need to do something about it, they keep saying to me, and this is, when I say they, I mean my sister-in-law, my best friends, like people that are really close to me, have said to me, both independently and recently, that, you know, China isn't doing anything. So why does it matter if the U.S. doesn't anything? If China can just keep emitting as much as they want, then, you know, we're all doomed anyway. Why do we have to change our behaviors and, you know, our industries for something that won't mean anything because China's not doing anything? So China is actually leading the way. And for those of you who can see the slides, this slide is full of text. This is the only slide that is full of text. And I'm proud that it's full of text because China is doing so much that we couldn't even fit everything China is doing onto this slide. You wouldn't be able to read it. We had to cut things out of this slide. And so just an example of what China's doing, they have firm commitments to peak their greenhouse gas emissions in 2030, and there's actually reports that they're going to hit this well before 2030. They're cutting their amount of coal, they're shutting down existing mines, they've canceled plans to build 100 new plants, and their coal consumption has actually been falling since it peaked in 2013. They're also putting penalties against polluters. It's now expensive to emit beyond legal limits. They're even setting up a national carbon market after a very successful pilot program, by the way, that EDF actually was involved with for the past 20 years and helped them set up. That pilot program covered 250 million people. That's almost as many people as in the US, and that was just a pilot program. So now they're extending that to the entire nation, which will be the first ever nationwide carbon market in the world. They're also setting records with wind energy. They generate the most wind energy of any country. They're even expanding their lead over the US and Germany. They're also the largest producer of solar, and they more than doubled their capacity in 2016. They have standards to cut vehicle exhaust in half. They actually were supposed to implement that in 2020, and they expedited that to 2018 because they're ahead of schedule. They have programs to retrofit buildings to make them more energy efficient. They have mandatory appliance labeling. They're tripling their nuclear power. They have 20 reactors under construction with another 176 planned. I know that nuclear can be controversial to some people, but it is really good in terms of greenhouse gas emissions. So that is why it's on this list, because that will help reduce their emissions. We're not going into the details of anything else that means. And another thing that some people think is controversial is that they're investing so much in high-speed rails to connect 80% of China's largest cities. Some people consider this great for the climate, and others think it sounds too good to be true, and there's actually more emissions there. But these are all actions that China is taking. They're taking it very seriously, and I heard most recently a few days ago that they're trying to now convince the US to do something, when in 2009 we were trying to convince China to do something. The tables have now turned. So those are all the specific details we have for you. We will send out more information on everything we said. We do have some slides with websites where you can go to find this information yourselves. I don't know how many of you can actually see this, but I will tell you that Skeptical Science is one of the best resources out there. They organize their arguments by different category like we did, but also by popularity. They actually quantify how popular specific arguments are, so they have them listed in order. They also have different levels of explanations. So you have some explanations that are basic, so very easy to explain and understand, but then they have some that are more intermediate and some that are advanced in case you want more information, more technical understanding, and maybe some literature you want to read about it. They also have responses to arguments in all different languages. So I definitely recommend checking out Skeptical Science. That's usually our first go-to when we get a question that we don't know the answer to. And then I just want to say before we go into question and answers that it's very important to remember that when you're talking to people that are coming to you with these claims, it's not just about the science or the facts in terms of how you respond to their arguments. So we don't have time to go into that here today, but as you can imagine, if you don't kind of relay the information in, the right kind of way, it could push people away farther. And so you want to be careful when you're getting into one of these confrontational arguments about climate that, you try to practice some of those, really good communication skills, like trying to stay calm. This has taken me many years to not freak out when someone comes at me with an argument, but just trying to stay calm and trying to, listen to them and agree and really understand where they're coming from, but then kind of try to push your own arguments in there too and try to really get through to them in a meaningful way. And also remember, some people just don't know. They're not coming to you with an argument. They're coming to you more of just with something they heard, and they just kind of want to know what you think about it. So I think I will give it back to Heather, who can lead the question and answers, and hopefully Scott and I can answer some of those for you.
Thank you, Alyssa, and thank you, Scott. That was all great information. I do just want to let people know that we are going to send out the slides and the recording for anybody who's experiencing technical issues right now to make sure that you can see all this great stuff that Alyssa and Scott are showing to us. But we'll go ahead and move to the Q&A portion. The first question is from Malin, who says she doesn't understand how higher heat and humidity lead to droughts and flood in the same areas. Can you guys explain that?
Sure. So, you can actually have, so as the climate changes, it becomes more volatile. So there could be increased swings from one state to another. So, where you get rainfall depends on kind of how the atmospheric circulation sets up. You can actually have over the same region, okay, let's take the Great Plains of the United States, for instance. You can actually have, over the same region, some years where you have drought, and then other years where you have flooding rains. I mean, if you look at the Midwest, where the U.S., we call it the U.S. Corn Belt, this is sort of a typical thing. There, if you recall recent news, there are some years where the Mississippi River's flooding, the rain just won't stop. There are other years where they're mired in really significant drought, and it impacts agriculture. What we're seeing is that over time, when you get these seasonal events, say in the spring or summer, they're becoming stronger. So you can actually have both becoming stronger. When you talk specifically about heat and humidity, it's a pretty simple relationship. So the increase in heat enables the atmosphere to evaporate more moisture off the surface, while at the same time loading the atmosphere when the atmospheric circulation comes in and it's just right for processing that moisture and causing more rainfall. So you can actually have that occur in the same region from year to year. Interestingly, even one of the other things we're starting to notice is that you can actually have the average not change all that much from over a long time frame, but how events are placed within the season could be changing. So in other words, you can get storms where you're having 10 inches of rain in a few hours, where we didn't have that 60 years ago, and then maybe 2 weeks without rain, and then boom, another storm. So the volatility is also increasing. So those two seemingly opposite states can actually coexist at the same time over the same region.
Thank you. That's really interesting. We also have a question from Anna at Ohio State University, she's a student there, who wanted to know, what common alternative facts surrounding climate change do you think will be the most difficult or most dangerous to deal with, and how do you think we should address those?
So, Alyssa, do you want to take that, or do you want me to take it? I mean, either way is fine with me.
Sure. If you have something you want to say, go for it. It's a loaded question. There are a lot of directions to take that, so up to you, Scott.
So, I mean, a couple things. I think the issue is that people struggle with the notion of uncertainty, and unfortunately, the connotation when you hear the word uncertainty seems to imply for many people that if you don't know something perfectly, you don't know it at all. And that's not necessarily true. So without getting into too many technical details, there are as with any science, as with all sciences, science is never finished. There's always more you can learn. So I'll give you a perfect example. When we talk about extreme events and how they're related to climate change, not all extreme events are created equal. It's much more difficult to try to figure out, say, how something like tornadoes or thunderstorms are changing as opposed to heat waves and drought. So anything that's closer related to big changes in temperature is much easier. So that's a sticking point. And it goes back to my argument about how people will cherry pick. They'll say something like, well, we haven't really seen tornadoes increasing all that much over the last several years. So that means climate change isn't real. And so, you can find little things like this that we are still trying to learn about, but that's why, we still need to push the science forward. There are kind of two sides to this. There's we know humans are causing climate change. We know that the global average temperature is increasing in relation to the amount of greenhouse gases we put in the atmosphere. We know that there are several effects that we're experiencing because of this, even to the point where some extreme weather events we can tie pretty well, to climate change. The capabilities are becoming really sophisticated in that area, but there's always something that's still left there to learn, and in all likelihood there will be. But I would put it this way: if I told you that there's an 80 or a 90% chance that we're going to see really devastating effects, and you come back to me and say, well, there's a 10% chance we won't, I would argue that, statistically speaking, you really need to take action. I know that if I was going to get in a car and I had an 80% chance of being in a car crash, you could be sure my seatbelt would be on, and I actually might not even get in the car. So, there's many little things like that are occurring in climate science that folks can quibble with and try to use to knock down the entirety of the body of information we have. But really, it's just one tiny little thing that we're not as certain as we could be or as we will be in the future. Thanks.
Okay. Our next question is from Scott, who's wondering what the best estimate is of the outcome if we do actually curb our greenhouse gas emissions immediately.
I think, this is Alyssa, I think the best outcome if we, which is what I was saying before, if we were, in theory, because this is impossible, if we were to drop all of our emissions off tomorrow, carbon dioxide accounts for around half of the warming that we're experiencing today. So even, like I said before, cutting off all of our CO2 emissions tomorrow, we would still probably have a little rise in temperature from CO2 just because there's a lag in the ocean. And so we actually wouldn't see the temperature begin to drop dramatically right away. And then over time, we would see it slowly go down. But there are other gases and aerosols that play a major role in warming. And so it's not just CO2. CO2 is only accounts for around half of the warming we're experiencing today. So methane, for example, many of you know coming from livestock, but it also comes from leaks in natural gas and landfills. And methane accounts for around 25% of the warming that we're experiencing today. But methane only lasts for a couple decades in the atmosphere. So if we were to cut all of our methane emissions tomorrow, and I know, again, this is theoretical, if we were able to cut those emissions, then in the next couple of decades, 25% of the warming that we experience today could be gone. So that would take a huge bite out of our warming. Based on realistic scenarios, because again, those are all theoretical, if we did a very extensive job at reducing our emissions of greenhouse gases, as strongly as we feel is even possible. We have these different scenarios, and the one where we take the most action still has us, staying, I think, around 1.5 degrees Fahrenheit, which is pretty much where we are today anyway. Actually, I meant 1.5 degrees Celsius, not Fahrenheit. So we're at 1.5 degrees Fahrenheit today, and we could definitely go down, but to stay below the 2 degrees C threshold that we've kind of given ourselves as wanting to stay below would still be pretty hard to do with all the actions that we have out on the table. That 2 degrees Celsius in Fahrenheit, by the way, is 3.6. So a reminder, we're at 1.5 right now. We don't want to get above 3.6. If we take immediate, extensive actions, we could keep it below 2, but we will get nowhere to where we were before the Industrial Revolution.
Okay, we have a question from Vivien, who's wondering, I think, Alyssa, mostly about your slide on China, because she's saying statistics on their economy can be called into question fairly often by investors. And, you see those horrible pictures all the time of the pollution in Beijing and other cities in China. So how do we know that they're actually implementing everything that you had listed on that slide?
That is an excellent point. And I think that's an excellent point. And there are a lot of different ways that we can know whether or not states and countries are being accountable for their actions. For EDF in particular with China, we have people that work on the ground in China. And so we know that these carbon markets, for example, we know that they have been in place. We know that they've been working. We have people that are very heavily involved with that. And absolutely, from areas of, what are the actual emissions from different sectors in China, there have been conflicting reports that, it was reported that it was actually more than they said they had emitted. And we're working on technologies right now where we can use satellites to actually see how much is being emitted in different regions. And that is kind of an up-and-coming science area where we could hold people more accountable for things. But I think overall, when you look at all the different areas that I said, like, for example, what's going on with solar and with wind, that's pretty easy to monitor and record. And there's a lot of people, involved in those projects and the reporting projects that, aren't from China, for example. A lot of these things are very international. And so I feel very hopeful, being more maybe of an insider in what's going on, but I think it's an absolutely great question, and that is something that's always going to be considered when kind of pulling all this data together on what is actually happening versus, what's just being reported.
Yeah, I think we have time for one more quick question. So there's one in here I've seen a couple times. This one specifically is from Cameron about how to respond to folks who confront you with alternative science or accusations that the legitimate climate science is staged or exaggerated to support our agenda. And I saw in another comment on this specifically talking about places like Heartland Institute putting out studies that contradict our science.
Sometimes the best way to approach those are to just show the source of that information. Scott and I can spend our entire careers having to address those alternative facts, and then we would get nothing done to actually solve the problem. And so, we really have to pick and choose what we really go at. But a lot of the time, something like the Heartland Institute, it's so ingrained in industry. That's where they get their funding. It's very similar to the tobacco industry trying to seed doubt on, tobacco actually causing cancer. And so by just attacking the sources of different facts and reports and documents, a lot of the times you can just get away with doing that, which is usually the easiest thing to do. But a lot of the times, just even being aware of all of the resources that are credible, which is hard to do, is something that, is very useful. And Skeptical Science, again, is one of those places that is very credible. We can vouch for that. It has a lot of scientific accuracy, and it has all of these different arguments written out. It has hundreds of arguments on there. So having resources like that at your fingertips, you're able to kind of poke around and make sure you know what's actually going on so you can share that with people.
Yeah, and we'll be sure to send you those resources in our follow-up email along with the recording and the slides so that, everybody can see everything in spite of the few issues that we experienced tonight with the program. I think we are just about out of time tonight. But if we didn't get to your question, please remember we will do our best to follow up with you over email in the next few days. And before you go, I hope you'll take our quick 3-question survey to let us know how we did tonight. But thank you, everyone, for joining. I really appreciate you taking the time out of your evening to come and discuss and listen to all of this with us. And I hope you have a great rest of your evening.